Okay. So today we'll be learning about functions. Okay, so what is function and why do we need functions? All these things we'll be covering today. First, let us understand what is function, why do we need function, and what is the use of function. Okay, not just in one language, every language basically we have something called as functions, isn't it? So basically, what is a function? As you can see over here, I've already written the points for you to take down. Okay, functions are nothing but these are sequence of instructions. Okay, sequence of instruction that performs a particular task. For example, if you have a task of adding, summing up, sorry, adding, your task is to just add. Each time you get a set of numbers, your task is to just add. So instead of writing the add code again and again, right? Instead of writing for loop, for I in range, whatever the number is from 0 to whatever n, instead of doing this, sum is equal to sum plus n, each time sum plus I, each time instead of doing this or using this, you can just create a function for this. Okay, these are set of instructions, isn't it? These are set of instruction. This is one statement. This is one more statement that you have in Python. So these are set of instruction that can be written in a block of function. Okay. So basically function is nothing but sequence of instructions. It's a sequence of instructions together, bundled together, which performs a particular task. That task could be addition, that task could be multiplication, that task could be finding out prime numbers, isn't it? Any task it can be. It is just nothing but set of instruction. That is what is function. Okay. Now, functions basically act like a black box. Why do we say this usually is if you can just consider your function to be a box, okay? Any function it could be. It can be doing anything. It can be finding out prime. It can be summing up all the digits. It can be reversing a number. Any function, any particular task it can be doing this box. So it acts as a black box. You need not know what it's doing. You can just send the inputs into it. Okay, what will you get? You will get the output. Whatever the function is returning, that is your output, isn't it? So this is a black box over here. It will take the input parameters and return the outputs to us. Okay, this is how a function basically work, isn't it? Whatever set of instructions are written over here, it will be there in the function block itself. Then why is it done? That one we'll be looking at in the next slide. Okay, why do we need function? All these things we'll be looking at in the next slide. Okay, now why do we need function? This is something which is very important, which will be asked in some of the interviews as well. If you know function, why do we need function? One is reusability. Reusability, you will just define your function once, and you can call it any number of times. For example, if you have a function, okay, if you have a function for finding prime number, finding prime number, then just give it an input. Each time you can, for example, the function's name is find prime. Okay, prime is a function name and takes a parameter n. So it will find the prime numbers between 0 to n or 2 to n. Okay, that is its task. You can use this function anytime, anywhere, just by calling it. How do you call? I'll say you it in later part of this one, later half of the lecture. So basically, if you want to call this function, just write its name and then send the parameter that you want to send, and it will be called, and whatever set of instructions are written within this function, that will be executed. Okay, so that's the reason why functions are used in reusability. So any as much as times you can reuse your function. Okay, so it's used in reusability. It's very much useful over that because it's reusable. Okay, next is your code will become very neat, concise, and easier to read. If you write the same summing up, the logic to sum your the digits of a number, for example 1 2 3, you want to sum up the digits, you can just write a function saying sum of digits. Okay, you can just write a function saying this, and then you can call it any number of times, n number of times. You need not repeat this logic again and again, right? So that's the reason why it also allows you to write a neat code. Modularization, obviously it's there. What is modularization? Basically, you are dividing your entire code into smaller and smaller manageable modules, into smaller parts. Okay, that is what is known as modularization. You can do that using functions once again. Easy debugging? Yes. If you have written function clearly, function block is defined properly, easily you can debug. Debug is if there are any errors, you will easily be able to identify those errors also when you have clearly defined functions written. Okay, that is the need for functions. These were some of the needs for function. Okay, reusability, need code, modularization, easy debugging. All these are some of the important features that we get from functions. Now, let's start defining function. How do we define function in Python? This is something that is very important for us to understand. Okay, so basically in Python, we use a keyword called as def. You can already see functions are defined using the keyword def. In Python, it's def. Parameters are placed inside parentheses. Function body is indented and may include return statement as well. So basically, how is your what is the syntax of your functions in Python? Nothing but only so much. First, write the def keyword and the function name. Okay, and the name of the function follows the same rules that you were using for what? Variables. Set of rules that you were using to write variable names, the same rules are applied over here also while writing the function names also. Okay, that's it. Use a colon. Okay, this is the bracket saying that this is a function. You can also write parameters over here. For now, we'll not see parameters. We'll just see what is the syntax. Okay, so here is a colon. And then whatever you write, it will be indented. For example, print hello, right? It will be indented. That means this is the function block now. Whatever is there in the indented part, that is the function block. Okay, this was all about the function definition. Now, how do you call this function, right? If I want to run this function, how will I call it? Somewhere in the code, you can just write the function name. Function name, that's it. And this particular function will get called. Whenever you write this, it'll search where is this function and then just call it. Okay. So we will also understand how this is actually happening, what is function calling, what happens in the memory when a function is called. All these things will be understanding. But before that, I'll just show you a small demo of I'll just show you a small demo. So I think Jupyter Lab itself I'll be opening. Okay, I hope you have understood all about function and function calling. Okay. Next is we'll understand about parameters and arguments in the next part. But before that, let us take a small demo of what is actually happening. Okay, let's start. Basically, nothing but you can just write def function name. I'll give name print. Okay, name print is a function. Okay, I think it's already naming is a function. This one, and then just indent it and then print just my name I want to print. That is the reason why I'm printing it in this way. Okay, now to call it. How will I call it anywhere? Just naming. If I do this and write the flower, this one, see, it's getting called and it's also returning. Whatever I had written over here, it's getting executed. That's it. Okay, this was all about a simple example which is saying what is a function, how a function is written in Python, and how it's being called. Very simple, nothing complex over here. Okay, now let's understand what are parameters and what are arguments in functions. When it comes to your functions, what are the parameters and what are arguments? Okay, I'll explain you over here using the example that I've written. Okay, so basically, we have two important terms. One is your parameter, and the other one is, and you have something called as argument. Okay, you have something called as argument. You have parameters, you have arguments as well. Now, Let us understand what are parameters. So basically when you write function, right, whatever parameters or whatever variables you have in the function definition, this is function definition, okay? Def with function name and whatever you write, right? Return a plus b. I'll say what is return also. So this is function definition. You are defining a function. So whatever variables are there within this, right? Within the brackets, those are your parameters. These are not your actual values. Okay, whereas arguments are your actual values that you're using when you call the function. For example, I'm calling the function add. I'm sending 2 comma 5. Okay, so I'm sending 2 comma 5 for this in the place of this. So these were not actual values. These are your actual values that you're sending. These would be your arguments. Okay, so basically you can just remember it in this way. Whatever is there in your function call, right? So function calling statement. So calling statement, whatever you have the variables or whatever values you have, those are your arguments. And whatever parameters or variables that you have in the function definition, those are your parameters. Okay. Those are your parameters. Remember this, it's very important. Parameters and arguments. What is the difference? You must be knowing it. I'll give you the definition in the next slide. But before that, let's look at this example. What is written? So written is nothing but whatever you are doing, right? Calculations or whatever, you are just returning it. So if I call this function now somewhere over here, okay, 2 comma 5, if I do, it'll come over here. In the place of A, 2 is going to be sitting. In the place of B, 5 is going to be sitting. And then when I do return A plus B, right? So it's basically like this. Return 2 plus 5. 2 plus 5 is 7. So basically it's returning the value to this part, to this function call statement. Later on, what can I do? I can just print this. Okay. So when I print this, I'll be printing 7. Okay. So basically the function is returning sum of two numbers. And here, as you know, that Python is dynamically typed language. So you need not have any return type or anything like that while writing the function also. Okay. So can anyone of you say what is meant by dynamically typed language and what is meant by statically typed language? What is the difference between these two? I've already taught you this. Why do we say Python to be dynamically typed and why do we say some other language as statically typed? Let me know quickly. We can't waste our time over here.
I mean, dynamic, we don't declare the data types.
Yeah,
And in static, we do.
yeah. So in dynamic, yeah, you're right. So in dynamically typed languages, basically during the runtime, data types or types of the variables are determined. Whereas in statically typed, in hand or beforehand itself, you'll have to mention what is a type so that the compiler or whatever interpreter, they get to know, right? What is a type and based on that, they do the operations. Okay. So that is why we don't have any return type or anything like that over here in function in Python. Okay. That is another advantage, right? An easier way for us to define our functions. Next, return statement. Let us understand in depth about return statement. See, ends the execution of function as soon as. So you might think return has no use, right? We could have done something like this only directly over there. In the previous a comma b which we had, you could have done this only, right? Print a plus b. But no. Then we say your return also has some other use case as well. So when it comes to function calling, right? When you call a function, for example, I call this function, there is a stack that is getting created in the stack, right? In the memory, I'll explain you this in detail. Okay. So for now, just for us to understand this one, let us understand this particular thing. What is actually happening when we call? So when function is getting called, right? In the stack, this is going to get created. A frame is going to get created. Function called frame. Okay. As soon as it enters this particular function, and then as soon as there is a return statement, right? This frame is going to get or deleted or erased from the stack. So return means come out of the function call. That is what it means, okay, basically. So return also returns a value back to the caller. So whatever the caller was, it returns a value to the, like I had explained you in the previous slide. Statements after return are not at all executed. So if you have a function called add 2 comma 5 a comma b, and then you have a lot of things before return a plus b, and you have a return statement, okay, you can return nothing or you can return anything, a or b. After that, whatever you do, right, it's not of any use. It will never be executed. As soon as you enter return statement, you're going to come out of the function call. That's it. So whatever you write after return, nothing is going to get executed. Remember this. Okay. Whatever you write after return, nothing is going to get executed. Okay. Next is, if no expression follows return, none is returned. That means, what it means is, if after return you don't write anything, just you write return and keep it as it is in a function. Okay. In a function called def add a comma b, if you just write return and don't do anything, none is going to get returned. Okay, none. It's going to return none. If you don't write any expression, it's going to return a none. The return type will be none. We'll look at this also. Okay, we'll look at this now over here with an example. What happens if I don't give anything in the return? Okay, so let's look at that. So I have my code. For example, in this itself, if I would have just returned the keyword return, and then if I would have called, right? Let me execute this. And then let me run this. See, it's not going to return anything. But if I print what naming is doing, if I print what happens, that one, let's see. If I print C, it's printing none. Because when I don't do anything, don't return any expression, it's going to return none. You can see this, isn't it? None is getting printed. Got it?
Yes.
Yeah. So that was all about return statements. Okay. You will have to remember return. Whatever you write after return, nothing is going to get executed. Next, calling or invoking a function. You have already seen an example in the demo where I've shown you. How do you call? If you have your add function, function name with arguments, this is how you call. These are your arguments, okay? So function call you have already seen. Let's understand that with another example later on. So always remember that function, if you're not calling it, if you're not calling a function, it will never get executed. Okay. It's never going to get executed. No memory is allocated for a function. Always remember, no memory is allocated for function block, whatever you write in function, right? For functions, until and unless you call it. Until and unless you call it. Only when you call the function, right? Only then a memory block is created. So let's understand how that happens. Okay, but remember this. Functions do not have any memory in the beginning. Only when you call them, a memory block or memory is used. Okay. That is when they actually occupy the memory in the space in the memory. Okay. So far we have learned how to define a function, how to call a function, what is function calling statement we have seen. Okay. And then what else? Okay, I'll give you another example, small example, making you understand in detail about function and function call. In Python, it's most of the things are allowed, okay, which were not allowed in other languages. For example, right here, I can written something like name. I'll written my name over here. Okay, I'll written my name. And here, when I'm printing, no, I can do this also. I can also assign whatever this function is returning. I can assign that into a variable called name. Okay, into a variable called name, and also I can print it. Okay, if I print only name also, I'll be getting the same thing because name is a variable in which whatever the naming function is returning, it's stored, isn't it? So now let's run this. So there is an error. Okay. What is the error basically? Return Pratiksha is what it's happening. So name is equal to hello. Name is equal to naming is something that we have written. It's giving an error. If directly I don't write print and then do it. Okay. So when I print it, so basically what I'm doing now is I'm just assigning the value, whatever the naming function is returning it into name, and then I'm printing it. Is this allowed? Okay, this is not allowed in Python. Okay, I missed it. But maybe in online compilers, it's allowed. Print got an unexpected keyword, argument A. Okay, fine. This is not allowed. Direct printing is not allowed. Okay. Okay. So this was all about so where I'm storing the whatever the function naming is returning, I'm storing it into the variable and then printing it. Next is what if your function is returning multiple values? What then? Isn't it, for example, here only one variable it was, I mean, one value it was returning. So one variable I used it and I've stored it. What if it's returning multiple values? Like, for example, it's also returning age. Okay. It's returning my age. It's also returning what I've done. BE is what I've done, isn't it? So it's returning all these, right? Then what will it do? What will I do? What if I write only name, only one variable? Will it take is it possible to store all the set of different values, the multiple values that are turning into one variable? No, that is why I may get, okay, so when I do print, right, see, it is storing it, but it is storing it in the form of tuples. Okay, I'll explain you what are tuples, but right now it's storing it in the form of tuples because we are returning set of values. So that's the reason why it's getting stored in the form of tuples. But what if I need it in different variables? For example, name, I want it in name. Age, I want it in age. Okay. And then qualification, I want it in qualification variable. In this way also you can do it. Now when I print name, only name is printed. When I try to print qualification, right? When I try to print qualification, only qualification is printed. B is printed. Okay. In the same way, what if I do this? Is this allowed? It's not allowed. It's going to give us an error. Let's run it. See, it's going to give us an error. What is basically happening is, see, Pratiksha, it's going to store it in the name variable. After that, you still have two more values coming, but it can't store those two values directly in one variable. Okay. That is when it's saying that too many values to unpack. You're unpacking two values into one variable itself. So that is when you start getting error. Instead, what you can do is only one value if you want it in this, and the rest of the values if you want it in some other variable, you can just add a star in between. Okay. Star of age in the sense, this means whatever the left out values are there after assigning one of the value to name, all the rest of the values will be assigned to age. Now, if I run this, it's going to run fine. Now, when I print age, right? If I print age, you are going to see that everything is there in age now. See, it's a list. List. I'll see you what is list, what is tuple, everything in detail. But this is how you do. Okay, is there any doubt in this? So far, any doubt?
No, ma'am.
Did you understand this? Why I have used star
No,
and
Yes,
ma'am, I
ma'am.
how?
did not.
Okay, which one didn't you understand?
That it's the 21st line. That name star. Why did we take star?
Okay, okay, listen. What is happening is, see, our function called naming is returning how many values? It's returning three values, okay?
Unit.
Three values. So what am I doing is, if I just take one variable, right, and then assign it to whatever naming is written, naming is a function. Okay, naming is a function. I'll remove all these so that you don't get confused for now. Okay, naming is a function. First, let me execute this block. And then let me execute this one. See, I've not got any errors. Okay. So basically what is happening is whatever the values you had, everything is getting stored in name itself. Okay. Now when I print name directly, what is going to happen? Whatever multiple values your function was returning, everything is getting printed, but in the form of tuple. Tuple in Python is basically written in this way. In your brackets, this parenthesis, okay? List is like this. We'll understand this later when the concept after functions will be going into arrays, list, and tuples itself. So we'll be understanding it later. For now, just understand this part, what is happening over here. Okay, this is what happened. Now what will I do is, I don't want everything to get stored in one variable only. So what will I do? I will take three variables for three values because there are three values over here. So let me take three variables. Name I'll take, age I'll take, and then qualification I'll take. Okay, and then execute it. No errors once again. So now when I print name, no, what is happening is unpacking is happening. This as a whole, this thing as a whole has come and sat over here in this part. Okay, because it's returning this. So when it comes and sits over here, right? Basically, what is happening is it's happening in this way: name, comma, age, comma, qualification is equal to first is Pratiksha. Okay. Second is 20. Third is B. This is what is happening here. So Pratiksha is going to come and store here, get stored here. Age is going to get stored here. Qualification is going to get stored here in this way. Got it? So this one might be clear now. So far, is it clear?
Yes, ma'am, clear.
Okay. Now the next thing that we had that I have shown you is, now I'll remove one variable. Okay. Basically, there are three values that is getting written, but I'm only using two variables. Okay, to store it. That is when I start getting error. Because Python doesn't understand. When there was only one variable, it got to know that I'll have to just put everything into one itself. But when it is doing unpacking, right? Once it has done unpacking, Pratiksha is in name. Okay, once it did unpacking. Now when it sees that only one variable again extra is there, it gets confused. What will I do? There are two more values, but only one variable. So it says that there are too many values to unpack, but there is no variable to store, no variable to store it only. That is when we get this error, unpacking error. Okay. So what we do is in this situation, so if you want, so basically you're controlling how your returns values must be getting stored. Okay. So what you're doing is the first value you're storing it in name, and the rest, whatever the values the function is returning, everything must get stored in age itself is what I'm saying Python right now. I'm making the interpreter understand that whatever after Pratiksha is there, because Pratiksha is getting stored in name. So whatever after Pratiksha is there, anything it can be. Hello, or it can be my address, right? It can be my address, anything it can be. It's going to get stored in age itself. So let me run this now. Let me print name. You can see that name is only having Pratiksha stored. Now, if I try to print age, right? Age will have everything stored. Age will have everything stored. Okay, let me run this first. I did not run this, so the previous one is getting up. Okay, let me run this and then let me run this. Okay, see, age is having everything stored. I can also do this. If you want only the last two values to be stored in age, I can add another value, another two values. For example, for age, I'll take a age variable. And for qualification, I'll take a qualification variable. And after that, how much ever values are there, how much ever value my naming function is returning, just store it in age is what I'm saying. Now, if I print name and if I print, sorry, let me run this again. Okay, now if I print name, I'll be getting name, isn't it? And then if I print age, you must see that only hello and Bangalore must be stored because age and BE, I've stored it in age and qualification. Now, if I run it, see, hello and Bangalore is getting stored. So basically, you're controlling where your multiple values that your function is returning must be stored. You're controlling that. Or else I can also do this, guys. See, what if I want name to be stored in name itself and Bangalore, that is location, to be stored in location itself. But whatever is coming in between, I want to store it in age. If this is what I want, I can do that also. Okay, let me run this and show you. Okay, now if I store name, I'll be getting name. If I do age, right? See, name has got into name variable. After that, star age I've used. Okay, location I've used. So Bangalore is going to get stored in location. The last value is going to get stored in location. But whatever is in between, no, 20, BE, hello, all of those are getting stored in age. Is this clear enough? So basically, you're controlling everything. Is this clear?
Ma'am, one small doubt.
Yeah.
Before this, you took a name twice the age. Like you took
Yes, ma'am.
age two
I
times.
also have the same doubt. Like you have taken age two time. Name star
But it is
age.
not showing anywhere.
Uh,
Where, where?
uh,
Like ex-
Okay,
uh,
here itself, is it? Like this.
yes, yes, ma'am.
Okay. Why isn't it showing error? I already taught you how is Python storing your this one. What? How is Python storing your variables?
No, ma'am, why? Because there are, I mean,
Yeah, age and age is
age
same. Why
is
isn't it giving? Huh? Why isn't it
error.
giving error is what you're asking, no? Okay,
Yeah,
I'll
ma'am.
explain you once again. I've already explained you when we were learning about variables in memory. Okay, variables in memory is a concept that we have covered. So there, what did we learn? If you write age is equal to 10 once and do age is equal to 20 again, right? So basically what you're doing, you're basically doing assigning it once again, isn't it? Or if you do age is equal to hello also, string also, there is no error going to come in Python. Why? Because in memory, this age is different, this age is different, this age is different. Yes or no? It is different. It's not the same ages. Okay. Basically, what Python does is whenever we do, if for example you're using 10 for a longer time, it will be cached in memory. Okay. If 20 you have used most of the times, 20 is also cached in memory. So when you do age is equal to 10, 10 is there in the particular memory. At 100 is the address. For example, you consider the address of 10 to be at 100. Age is just going to point this. So as soon as you do age is equal to 20, no, for example, 20 was it at 200 address. Age is now going to point 20. Okay. And as soon as you did hello, if hello is stored or if it's not there, it will create a memory for hello. And then age is going to point here. So each time you're doing changes, it's going to point to a different address. That's the reason why over here, when you did star age, right? Star age was having what and all? It's having 20, BE, and hello all together in the form of list it was having. So basically, what is happening in the memory is, what is happening in the memory is name is stored. Okay, name is stored. Name is stored. Pratiksha is stored in name only. So Pratiksha, a memory is created for Pratiksha. Now name is pointing to that memory. At 100, you can consider it to be memory. Now, Python will check if this particular, see, next is star age, isn't it? After that age comes. So it knows that last one value I'll have to leave, but whatever is there other than that, I'll have to create a list of it. 20, BE, hello. And this list is stored in a memory, okay? I'll show you how lists are stored. This is not typically how lists are stored, but consider the starting point of list is 1000. Now, what will age do is it will start pointing to 1000. That means this list, starting point of list. As soon as you did again, age is equal to naming. So, whatever is left is once again done in. So, Bangalore, a memory location is created for Bangalore in memory. Bangalore is created. For example, at 1001, we have Bangalore, or at 1100, we have Bangalore. Now, age is going to point to this address. So that is why after you did everything, when you're printing age, it's going to print Bangalore. It's not going to print this one because this is already age is not all now pointing to this anymore. That's the reason why it's going to print. That doesn't mean this is deleted. It will be kept in the memory. Later on, if you're not using it for a long time, garbage collector is something that is going to clean this part. Got it?
Yes, sir.
Yes, ma'am. Basically, it is
Okay.
updating the memory. Okay,
Yes. Yes.
got it, ma'am.
Whatever is there, yeah, it's going to point to a new memory location. Okay. In
Yeah.
Python, that is what. If the same thing, if you would have done it in, why is it allowed is because there is dynamic typing.
Even
Okay.
it
You
is
need
same.
not. What?
No, even it is like same in Java also. We will be overriding it. Like
Yeah. In Java also, it will be overriding. But when it comes to Java, right? Sorry, wait. I'll minimize this. Okay. When it comes to Java, no, you were writing your data type also over there, isn't it? Once again, if you do
uh,
int a is equal to 20, it would have given you error. Yes or no?
yes, we will be writing only a is equals to 20 over.
Yeah. So if you do a is equal to 20, obviously here it is happening. But in Python, you do not have this condition only. In runtime itself, everything is happening, but still it's not giving you error at all. Okay.
Yes, ma'am.
So that is why you might get confused. Okay. Next is, I hope this is clear. You understood why we use star, right?
Yes, ma'am.
Yeah. So we'll be solving questions where we'll be using star also. This week functions question also will be solving. Okay, so whatever we are learning concept based on those itself, I'll be giving you questions, nothing extra. Okay, each time we are solving, each time we are learning a concept, we'll be solving questions related to that itself. Like last week we had done, there was nothing extra that I've solved or used while solving questions. Even if I'm using something extra, for example, using end and all those, I will explain you it in detail while solving the question itself. That is why I'm saying these basic things. I had already taught you this case, right? If you do not remember it, if you don't revise, no, you'll start forgetting things. That is when you start solving tougher questions in lead code, you will be stuck. You will not be knowing what to do next. If you know all the basic things, no, you can do anything. You can write your code in any way because everything is right. You know the syntax better. So you will find your own logic and you will write the syntax. That is why I say be strong in a language. You can frame your own sentences later on. If you know language, you can say a sentence in different way, like I do. If I want to say go and do that work, I can say go do that work. I can also say go and do that work. Right? Same thing it is. If you know logic, you can create your own logic. If you know the language, you can write it in any way. Just the thing is, your syntax must be right and your code must be optimized. For that, you'll have to practice each time. Once you write the code, try to see what is the optimized solution. Try to see what is the memory it's taking. Try to find out what is the time it's taking to get executed. You might have heard about big O, Fen, and all this. We'll see what are these also later on when we start solving actual lead code questions. Okay. So that is why I say be strong in one language. That is more than enough. Okay. This was all about unpacking multiple values that is being returned by your function call. Uh, function definition. Next is, I've already told you what is the use of star. Next is, let us understand nested functions. Let us understand nested functions. Nested function is nothing but, you already know nested if, nested loop, nested conditionals, right? In the same way, nested function is nothing but function in function. Or you can say not function in function basically. Basically, nested function is nothing but calling a function, calling a function from another function. Okay, that is what your nested function is. Another function. nested function definition. So nested function is nothing but calling a function from another function. That is what is the definition of nested function is. I'll show you an example directly over here itself. Okay, calling a function from another function is the definition of nested function is. Sorry. Let us see an example. Okay. Let us see an example. I have a function called as what? Def add is my function. I have two variables a comma b. Okay. Inside this function, I will do one thing. Or else we can do this. Def calculator is my function. Okay. A comma b is something that I've used. Now inside this calculator function, I'll have different function calling. Like I'm calling once add function. So to add function, I'm just calling it. I'll define it. Okay. A comma b, if I call, it must add and give me the value. I can also print this over here only. Print add of a comma b. I can do this. And then print subtraction of a comma b. So basically you can see that I am calling multiple functions inside this calculator function. But if you don't define those functions, no, you will start getting an error. So that's the reason why first you will have to define the function. After calling the function, if you're defining it over here, no, you will get an error. This is not allowed. After calling, if you're defining, it's not allowed. You'll have to define the function first. You'll take a comma b as a variable, and then you'll return what? A plus b. Add function is basically doing addition. Then define subtraction. Here also a comma b is a variable that you're taking. And then what are you returning? You are basically returning a minus b. Okay. That's it. You have defined your two function, and in the third function called calculator, you are basically calling the other two functions. This is what is the example for nested function is. Here you can see calling a function from another function. That is what is your nested function. Now let me run this first of all, and then let me call calculator 2 comma 3. Now if I execute, see, 2 plus 3 is 5. So as soon as it enters 2 comma 3 over here, first is print a, add of a comma b is happening. So it will come over here, execution. Point of execution is over here now. Return a plus b, it will return a plus b. So when it's written, it's going to come back over here. So print is there. Print a plus b is going to happen. Then again we have print sub of a comma b. That is again we are going to get into this function. Here now the point of execution is over here. It's going to return a minus b. So that is when we print a minus b, we are going to get minus 1. Is this clear? Nested function?
Yes, ma'am.
Okay, no doubts, right? If you have any doubt, please do ask me now.
No, ma'am, no, ma'am.
Okay. Now I'll be explaining you. So far, we have seen nested function, calling a function from another function calling statements we have seen. But what is actually happening in the memory is something that we will have to understand in the depth. So for that, let's get into whiteboard. Okay. So what is actually happening in the memory is something that we will have to understand. But before understanding that, we will have to get to know two important terms. Two important terms. Okay, one is program and the other one is something called as process. So what is program? What is process? Once again, this is one of the interview question that can be asked. What is the difference between a program and a process? So what is program basically? Okay, so what is program basically? What is this and what is this? Something that we will have to understand now. Yeah. Okay, so what is program? I'll just write down the statement first. So program is nothing but a program is just code, okay? Program is just code plus the data stored plus data stored on disk. Okay, remember this. A program is just set of statements of code plus it is code plus the data that is stored on the disk. What is process? Process is a running instance. Running instance of a program. Process is basically running instance of a program, whereas program is just a code plus the data that is stored on the disk. Now, what is an example for program? So whatever you were doing it so far, no, whatever you were doing over here so far in Jupyter Lab, if you would have done in your local system, you would have saved each and every file as .py. Yes or no? So you would
Yes.
have stored, yeah. So whatever you have written in your .py, right? That is nothing but program, basically set of statements or set of instructions. So .py, when it's not running, then it's called as a program. .py or your .exe file or your .c file or .java file, whatever you have, no, these are your program. Nothing but it's data that is stored on the disk in your local computer's disk, no, in the hard disk. That is where it's stored, all these. Okay, program. It's just a code set of instructions that are stored. So now, for example, over here, you had your set of instructions. These are your set of instruction which would be stored in your .py file. So this is nothing but program. But when I execute, when I do shift enter, no, when it starts running, that is when it's called as a process. When the same .py file you start running it or executing it, that is what is called as a processes. Remember this. Okay. Program is basically passive. It's passive. It's not running. It's just there in the memory. That's it. It's just saved. It's not running. It's just instruction that is basically waiting to run. Okay. Process is nothing but it's a running instance of a program. Okay. So I hope this is clear. And now, as I told you, program, once you write your program and store it and save it, you save it as .py. And once you execute, right, that is when it becomes process. So whenever you execute, no, any program, any file, for each and every file that you execute, for that is a process, isn't it? Each and every file that you execute, each program that you execute, it's a process. For each process, no, each process that is getting executed, or each program that is getting executed, that is a process, has the following. This is very important. Remember this forever. It has its own memory space. Own memory space. It's a bit theoretical, but interesting as well. You will understand how basically call stack is there in function call. Okay, and it has a program counter as well. PC, program counter. Okay, PC, program counter. Each process, as soon as you run this .py file, no, that is a process now. So each process, each program file that you're running will have its own memory space. It will have its own program counter, as well as it will have its own a stack. It will have its own heap. It will have its own heap memory assigned, and also it will have its own code segment area. Okay, it will have its own data segment area as well. Data segment, code segment area. And along with that, it has its own process ID as well. Process ID also. It will have its own process ID also. So each and every program that you're running, no, it will have its own ID for that particular process a particular ID is specified. It'll have its own stack, it'll have its own heap, it'll have its own code segment, it'll have its own data segment. So what are all these? I'll be explaining you in detail. It'll have its own memory space. So in that memory space, all these things would be there. Process ID, stack, heap, code segment, data segment, program counter, everything is stored in the memory space. Just take a screenshot or just write it down. Okay. Next, we'll understand in depth what is actually happening in the memory. Memory layout we'll be looking at. Now let's understand the memory layout in Python. Okay. So for example, I have a .py file. As soon as I run this .py file, a process is created, isn't it? With a process ID of 1180, for example, PID, process ID 1180. For this process, a memory is occupied, right? See, memory space is utilized. Its own memory space it will be having. How will that memory space actually look like? It will look like this. This is your memory, a part of your memory. It will look like this. So first in the top, it's always all the command line arguments that are stored. Command line arguments and your environment variables which are there in the file. We have not yet seen what are command line arguments, what are environment variables. Environment variables are also type of variables. So whatever environment variables are there or whatever command line arguments are there, those in this process, in this .py file, right, that will be stored in the top in this way, in this part of the memory. Okay, after that, stack is there. In the process memory, this is your process memory layout. Process memory layout, something which is very important for you to understand. Okay, this is your process memory layout entire. Then comes stack. So what will be stored in stack basically? Local variables. So whatever local variables are there, that will be stored in stack. What is local variable? Something which is there within the function. We'll understand what are local variables in depth in tomorrow's class. For now, you understand that local variables are stored in stack, as well as whatever your function is returning, right? Return addresses. Those are stored in stack itself. Okay. Along with that, frames are also stored in stack. What frames? Function call frames. As I told you earlier, when I call inside calculator, I called add and sub function, right? So first in the stack, frames, when I say in the stack itself, these frames are created. First, what did I call? It was cal. After that, what did I call? It was add. After that, add return. So it gets deleted after that. Once there is a return statement, then what was called? Sub was called. So these are frames, call frames, function call frames. These are getting created in the stack part of the memory itself, of the process memory. Okay, all these things are getting created over here. This memory is utilized by function call statements. After that, we have something called as heap memory. Okay, we have something called as heap memory. In heap memory, dynamic memory or dynamically allocated variables, whatever dynamic allocation has been done using malloc and calloc. Do you know what is malloc and calloc?
No,
Do
ma'am.
you know? Okay. Malloc and calloc is basically nothing but during runtime, you're allocating memory. Okay. That is what is known as using malloc and calloc, two functions. It's built-in function. Using malloc and calloc, basically during runtime, you are assigning memory to any particular variable. That is what is known as malloc and calloc. A dynamic memory allocation is. So we'll understand malloc and calloc further in the future when we are solving questions, but not now. Okay, because it's not important now, right now. So dynamic memory allocation, whatever is done, no, all those are stored in heap itself. Okay. Along with that, your objects are stored in heap itself. Whatever objects you have in your code, right? All those are stored in heap. Classes and objects. Object is a blueprint of this one. Class is a blueprint, object is an instance of class, right? So that object is also stored in the heap itself. Okay. Memory is assigned to it in heap part of the memory, whole memory. After that comes the data segment. Data segment. Okay. In data segment, basically your global variables are stored. So remember, local variables are stored in stack. Global variables are stored in data segment area. Along with that, static variables are also stored. Just remember, static and global variables are stored here. We'll understand both of these later. Okay, all these are stored in your data segment area. Okay, after that, we have something called as code or text segment. Text segment. So in this, basically what is stored is your instructions .py, which is there, no, that is stored in this part. Whatever is written within this. For example, over here you had a code. If you would have written it in a .py file, this was your machine instructions, right? Those machine instructions are stored in this part of the memory. So each of this .py file gets assigned a memory. So much of memory is assigned for just one program. Okay, so whatever command line arguments are there in this file, that will be stored here. Whatever function call frames are there in this file, so whatever local variables are there in this file. For example, if you come to this, what are your local variables? Your A and B are local variables. Isn't it? These local variables are stored in this part. Whatever dynamic memory allocation is done, those are stored over here in the heap. Whatever data segment, that is global variables are there, those are stored in the data segment. Whatever code segment, whatever this code set of instructions that you have, that will be finally stored in the code segment area. Is this clear? For each and every .py file, so much of memory is used. Stack, heap, everywhere. This is the memory layout of this particular file. Is this clear?
Yes, ma'am.
Okay. And this data segment, no, it's also known as BSS. See the full form of BSS? Data segment area is also known as BSS. Okay, basically, it's not known as BSS. Basically, data segment area is split into two more parts. Okay, it is split into two more parts. One is BSS and the other one is for. So here itself, in data itself, there is two division. One is for BSS and the other one is for initialized data. Initialized data. So whatever variables, global variables, for example, A is equal to 10 is initialized. Initialization means you have assigned a value to variable. That is what is known as initialized. So this initialized data will be stored in the initialized data segment area of data segment area. It will be stored in the initialized data part of the memory. Whereas BSS is something that stores uninitialized data. If the same global variable was only written so much, A and left as it is, okay, that is uninitialized, isn't it? Uninitialized. So that will be stored in the BSS part of the data segment area. Okay, got it. Next is one more important thing is how does stack grow? How does heap grow? So if you have multiple local variables, no, how does it grow? Stack basically grows. Stack grows downward. Remember this. Your stack area grows downward. So if you have A variable, B variable, C variable, it grows on going downwards in the memory. So this is address 100. This basically it's going downward. Okay. Your memory is actually getting stored in a downward direction. From up till down, it's going to go. Whereas this one, which is this heap, no? Heap grows in an upward direction. Grows in upward direction. Okay. This is something which is very important for us to be knowing. Grows downward. What grows downward? It's your stack. What grows upward? It's basically your heap layer, heap memory that grows upward direction. You can understand that in detail. Okay, further, if you want to know what is upward, what is downward, just go search it. You'll get to know what is upward and what is downward. Basically, it's all about your memory, the addresses. Okay, it's all playing with addresses. Is this clear? And this is read only part. Remember, code or text or machine instruction. No, this is read only. Once it's running, once the process is running, you can't change this. So it's read only. Remember this. Is this clear? The memory layout?
Yes, ma'am.
Okay. This is your complete memory layout for one particular file. So if you have 2 to 3 files running, in the same way for each and every 2 to 3 files, you have your process memory layout defined in this way. Remember, this is your entire process memory layout. Okay. I think this was enough. This is enough for today's class. So we have seen what and all did we see today? We have seen how to define a function, how to call a function. After that, we have seen multiple value when a function is returning, how to assign it and how to use it. Right. After that, we have seen what is called this one. What is that? Program, what is process, and what and all does a process have also we have seen. So see, each process has memory space, that is this memory space entire thing, and each memory space will be having program counter. Program counter is something which is basically keeping a count of the instructions. Okay, program counter is basically a counter that is kept in the memory. Then you have stack, heap. You saw that stack is a heap is a, you have data segment area, you have code segment area or text segment area. All those I've explained, and its own process ID. So each and everything will also have its own process ID as well. Okay, this was all about process memory layout for any function, any set of instructions that you write. So what happens is basically who assigns this memory? It's basically your OS. As soon as you run this file, no .py file, your OS is the one that comes as a hero, right? Your OS is the one. As soon as you run or execute this, OS is something that is going to assign the memory in this way. OS is the one that is going to load the entire code into memory and divides it into this way. The entire code, it's going to divide it in this format. So entire code, for example, you had your entire code here. Your OS, once you start executing it, it will divide it in this way. All the function call and everything will come over here. All the dynamic memory will come over here. All the global variables will come over here and sit. All the code instructions, other code instructions like print, all these are going to come and sit over here. But this is what it is, how it's done. OS is the one that is actually helping you out in doing all these. You need not worry about memory or else. Is this clear so far, whatever we have discussed in today's class?
Yes, ma'am.
Yes, ma'am.